This might be my next video. We just plugged in our Christmas tree. It is a fake Christmas tree with the pre-hung RGB LEDs, and it's supposed to be just a constant white, and whatever I do, it just blinks like this. If I goof around with the controller, it will sometimes do what it's supposed to. I'm trying to just do solid white. I've got my oscilloscope down here and a meter, and we're going to see if we can figure out what's going on. Just briefly, this is supposed to be a 30-volt string DC powered LEDs. This is the controller. Here's our AC input. This appears to be a AC to DC power supply. I'm not going to be able to read it, but I'll include a picture. It's made by GE. Oh, look. My lights just went solid and turned on. So banging this around got it to work. Anyways. This is a AC to DC power supply, DC coming into here, and this is the controller. I don't know how this controls the LEDs in that it's just two wires. If I goof around with this, sometimes the LEDs will work properly, but on the next power up, they'll stop working again. Since it's fully lit up right now, I will take my ammeter and my oscilloscope and let's look at the output of this and see what it's doing. With the solid LED lights, we're pulling approximately 0.3 amps, and this has a rating on it of 30 volts. I just bared back the insulation here, so I'll measure that with my DMM here in just 1 second. Basically 30 volts. It's showing 29.28 volts, and it is DC. Probe connected, and we're looking at it here with the scope. I'm on 10 volts per division, and the LEDs are a constant white, and we see that we've got approximately 30 volts, and there's no data or anything happening while the LEDs are constant. Okay, it's working right now, and it's now in the multicolor mode. I've got my oscilloscope probe on, and look what's happened here. The polarity has swapped. Okay, so this is interesting. In the multicolor mode, we're pulling approximately 0.5 amps. I'm going to have to change one of my earlier statements. Earlier, I thought that each LED was an RGBW, or just a RGB and getting the white. And now I think that on my tree, anyways, we are just two colors. So it's still working right now. I'm in the white only mode. I am pulling about 0.3 amps, and I'm positive 30 volts. If I go to the color mode, I'm still about the same current, and the polarity has swapped. And I'm going to go to this mode where it flashes between the different colors. This might be hard to see, but this is just white and amber, white and green, white and amber, and something back here, white and blue. So I think that my tree has 3 types of LEDs: white and red, white and blue, white and amber. And I don't know what this is. I don't know if that's data, but I think it's just a dimming mechanism. I've cut this out, and the tree now is running to these alligator clips to my power supply. I have this set to voltage limit at 30 volts and 3 amps. And there's my polarity. I'll turn it on. There we go. There is my white. And I'm pulling a half an amp, where earlier I was pulling about 0.3 amps. That's what we saw over here on the oscilloscope. That pulsing low wasn't data. That was just dimming the LEDs. So I'm going to switch polarity. And now we're multicolor. But look at our power now. We're 2.8 amps. And this is quite a bit brighter. And that the pulsing we saw there was just limiting the current. So that's going to be a pretty stout power supply. We're going to go take a look at this down at my workbench and see if we can figure out what's going on. Worst case, we normally just run white, and I could just hook up a power supply like I'm doing right now and get our white color. Interesting here that this is about 16 watts, and that's because we're not seeing that pulsing low, which is reducing the current or the power going to the LEDs. I've seen a couple of these things on eBay or Amazon, and they are not typically rated at 15 watts. Very interesting. What I'm going to do now is I'm going to vary this voltage here, and we're going to see what effect it has on the lights, and if we possibly could go with just a 24 volt AC to DC wall adapter. So I've got this set to adjust in 1 volt steps, and we can see that I am adjusting the brightness here, and however, a 24 volt is not going to be enough voltage. So we have enough LEDs in series that 24 volts will not work. We're going to need roughly, I think, at least 27 volts DC. I've got it hooked up on my bench. It's been off for probably a half hour, and look at that. It's goofed up, and it is about 3.5 hertz between this pulse. Chuk, 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 chuk. And that's what I was seeing on my tree. So, we'll dig into it. This experiment, I have the controller hooked up to my bench power supply, and I have it over here on my scope, and I'm not getting that pulsing noise. So I'm going to just cycle the power a few times. So possibly this is okay and the power supply is bad. Let's do a few more experiments. Back to the Christmas tree power supply, and we are pulsing. Now we're looking at just the power supply, and I think we have found our problem. And I've got some side light on this so you can see the printing on these little GE boxes. And here's the back side. So this is my temporary solution. I am using a variable power supply that I purchased off of Amazon. This can do about 32 volts. And I did find that my controller also was having a problem. So it was both the controller and the power supply that had failed on this Christmas tree. I will work on making an actual little controller later on that will allow the tree to go, into the different modes and different colors. I just wanted to show really quickly the relation to current and the voltage here. So I'm going to adjust this. So we'll change by 1 volt steps, and we'll go to 30 volts, and our current jumped to quite a bit. And you also might have seen that the LED, the Christmas trees, got quite a bit brighter. So I'm going to go down to 29 volts. That's the rating of the power supply. You can see it's quite a bit dimmer. 28 volts, even dimmer. And we are basically off at 23 volts. I have the voltage reversed, and you can see at 29 volts we're running a whole lot more current. Also the color LEDs run at a lower voltage. This is the connection or the schematic of the LEDs on the Christmas tree that we have. We can see the anti-parallel LED, and each LED consists of either a white and a red, a white and a green, or a white and a blue, with each LED in series. The white LEDs have in general, a higher forward voltage drop than the color LEDs. That is why we see a big difference at the same voltage having a much higher current for the color. So we can see here at 29 volts for white, we had approximately 0.31 amps, which is 9 watts. And for the color, we have 29 volts, 2.5 amps, 72 watts. We would need to take this into consideration if we built a custom controller, and also take this into consideration for when we're purchasing a replacement power supply and controllers. As I have shown in the other sections of this video, I ended up just going with a power supply for right now. And if I look in Amazon here, we have 29 volt, 13 watt power supplies, and this power supply would be sufficient to power the Christmas tree. However, note this is just a power supply, so it won't do switching back and forth between different colors or dimming or anything like that. Some of these power supplies, say for example this one, is rated at 6 watts, and so it would not be sufficient to power this Christmas tree. If I try to find a controller with the built-in power supply, I couldn't find many just controllers. So these seem to be pretty popular, but most of these are not high enough power. Say for example this guy is 6 watts and 30 volts. After the controller, it's probably lower than 30 volts, so let's call it 29. And we can see that it would not be enough for white, and surely would not be enough for color. This seems to be a pretty popular type of power supply, but I cannot see anything that would directly work with the color. Here is the next step in my Christmas tree repair. I still have the same power supply that is supplying 30 volts now, and I have a L298 H-bridge circuit board I purchased off of Amazon. These are just like $4 or $5. And here is a eval board for a Tiva M4 microcontroller made by TI. I just wrote some quick code to implement 2 pulse width modulation signals that feed into this guy, so I can switch back and forth between the two anti-parallel LEDs. This guy does run a little warm. In that it's kind of an old technology. It uses standard transistors, so there's at least going to be a 2 volt, possibly more, voltage drop across this device, and that's why it has the little heat sink. I would like to implement this with MOSFETs. Anyways, so I just did some really quick code, and the idea is here that I can push this button and I can switch between different modes. And so this is just dim white mode, a dim color mode, and you can see that we're not drawing a lot of current. And I'll push this button a few times, and so right now it's in a dim up and down mode. Well, that's about it. I think I'll make a little circuit board that combines all of this together, and maybe I'll detail that in a later video. Anyways, that's it for now. I'm going to call this video done. Thanks. Bye.